Hey everyone, I'm Nicolai Parlog. I'm a Java developer advocate at Oracle, and I'm here to talk to you about the Java module system and Java modules in real life. So we're going to talk about why to use modules in the first place, and then we're going to look a little bit into incremental modularization, the process of not turning all your jars into modules, but just some of them. And then we'll discuss briefly some tricky roadblocks that you might, hopefully not, but that you might face. And then at the end, we're going to look at how to get out of it if it's really necessary, which I hope it won't be. And then we close out with when to use modules and when not to use modules so you can make an informed decision. So let's start with why to use modules in the first place. So I have here this Maven dependency this Maven project that depends on Guava. And at the bottom there, I have an import for a class from the checker framework. So the question is, does this compile when you build it with Maven? So I have a dependency on one thing, but I use something else. The answer is yes, this works. Maven pulls in all dependencies and all transitive dependencies, and this actually compiles. Should it, though? I mean, I'm using something I'm not depending on, so it's really questionable whether this should compile in the first place. If you use the module system, then it wouldn't, because you did not declare the dependency on the checker framework in your module declaration, and hence the module system would not let you compile that. The module system makes modules and dependencies more explicit. Another advantage is that you can have self-contained applications, meaning that if the application expresses its own modules and all the modules that it needs, including dependencies, all the way down to the JDK eventually, then you can build a system, in this case, in a runtime image that contains exactly those modules. And that's really easy if you use modules to express all dependencies. Something else that the module system really shines at is at defining APIs. So you have a screenshot from a project that I maintain, and you'll see there that it's org.jnode Pioneer is a package, and then there are other packages called internal, and then some more. So which of those can I use as a user of this project? Well, probably not the one that's called internal, but what about the other ones? Well, if you look into the module declaration, it's actually really simple. It lists explicitly which packages I can use as a user of this module, and more importantly, it enforces this at compile time and at runtime. So both of those situations, if I use something I'm not supposed to, I will get an error. So how do you stop projects from using your internals? With classic code, you could just name something internal or whatever. But if you use the module system, then you can protect everybody outside the module from using something. But the cool thing is you can still export a package internally within your project. So if your project consists of several modules, you can make sure that some of those modules can use an internal API, but others can't, and also others outside of your project can't. That's something that is unique with the to be able to do with the module system. Then there's the problem of illegal access errors that I have here. They happen when you use something that you're not supposed to use. And I brought these here from Spring LDAP, Error Prone, and the Vera PDF library, and they are all already fixed. So what this was these libraries in the past using JDK internal APIs when they shouldn't have. They fixed this, so it's not an issue at the moment anymore, but this goes to show that if you don't have a boundary that protects internals, people will start using these internals. And that means that when these internals change, and they can do that in any minor update, these internals can change, then that could break your project or your code, which is not something that you're really looking for in any minor JDK update, for example. And that also extends to other libraries. You might be using libraries and depend on their internals accidentally. If you have modules in place, then you cannot do that accidentally. So generally, dependencies on internals of the JDK, on frameworks, on libraries are a risk. And the module system first prevents them, but if you really, really need them, you can do that with these add exports flags, and then you at least have an explicit marker that you're using some internal API, and that you need to go ahead and fix those. Then there are services that were introduced in Java 6, and they use the service loader class to load them. So which services does a jar use? With modules, it's really easy. If you use modules, it will list which other services it uses. This is something that you regularly don't see without modules. Which services do you provide? That's something that you can see without modules, and that's in this meta-inf/services folder. You will see files, but they're not straightforward to parse. This is much easier. Once again, the module declaration has all of these listed for you and says which services are provided with which class. And that just makes it much simpler. The other thing the module system provides is a new abstraction, a new singular point for a lot of information. So if you think about what makes up a module, a jar, a piece of your code, it's something that has a name, it's something that has an API, that has dependencies, might have services, probably requires some documentation. And without modules, where are those information? The name is hidden somewhere in the build tool. The API, you just don't know. Everything that's public is probably part of the API. The dependencies are listed in the build tool. Services are somewhere off in the meta-inf folder, as we just discussed. And high-level documentation could be a README, could be in your Confluence of your project or wherever. But with modules, all of these pieces of information come into the same file, and some of them must be listed, like the name, the API, dependencies, and services, and the other, like documentation, you can also put there. So the module declaration is a great place to also add documentation. You can describe the central abstraction of that module, what its contract is, what its design is. You can explain why there's a dependency that users might not expect to find there. Why is the API formed the way it is? Why do you allow reflective access? Why do you use these specific services? Anytime you make a decision that is not obvious, you can document that really well in the module declaration. So the module declaration define and document a project. And those are verified, leaving the comments aside, these are verified by compile and runtime, so they're always up to date by necessity. Other tools can evaluate them, and they're very, very obvious point to review. This is something that any code review, if you do those, if you do pair programming session at the end of those, that would be a good time to really look into the module declaration and try to figure out whether all the changes that were made there really make sense. Because modules are a living representation of a project's architecture. This is not like the drawing that some architect put on a whiteboard 2 years ago and that's still running around somewhere in your wiki. No, this is like a real-life representation that evolved with the rest of the system because it had to. And I think those are all important benefits to have in a large project specifically. But we'll talk later about how size comes into this, how project size come into this. So for now, let's focus on how to get there. Because in an ideal world, you just sit down, create everything as modules, and then you're good to go. But that's probably not possible either because your project might just be too large for it, or you might be using dependencies that don't come as modules yet. So let's see how incremental modularization works, at least on a high level. So why would you even consider this? Because a partial modularization gives you partial benefits. I've convinced you that the module system does give you benefits, then having half of your system as a module gives you roughly half of those benefits. The other part is that some of the roadblocks that we're briefly touching on later, you can avoid them by using this incremental modularization approach to not modularize the stuff that's causing issues. And overall, it makes the whole process more relaxed. You don't have to do it all in one sitting. So why is it even an option? Most module systems are either everything is a module or the module system doesn't work. But when the JDK was released with modules, then the JDK was modularized, but everything on top wasn't. So by necessity, there had to be a boundary between the modularized code in the JDK and the non-modularized code everywhere else. And this boundary between this legacy and this between modules and the legacy systems, this boundary can be moved. And that's what incremental modularization is about. On the left, you can see, some drawing where below the line you have all these blue modules, and above you have these yellow boxes which represent regular jars. And then incremental modularization means moving the boundary between them and not having everything as a module at once, but getting there slowly. And there are two big technologies here at play, two big enablers of these features. That's unnamed modules or unnamed module. We're going to stick with the singular. And automatic modules, that's definitely the plural. I'm going to explain both of them right now, but the important thing to understand is that the class path and the module path both exist at the same time, and whatever kind of jar you have, whether the jar is just an old plain jar or it's a modular jar, you can put each of them on each of these paths, right? So that's very important. So let's talk about the unnamed module first. All the jars that end up on the class path, they all end up in the one unnamed module. You usually, technically, every class loader has one unnamed module, but we can ignore that. Everything that's on the class path ends up in one unnamed module. Even modular jars, that's very important. Even if one of your dependencies does indeed deliver the modular jars, you put them on the class path, you end up in the unnamed module. The unnamed module has no name. It can read all other modules and exports all of its packages. So it's only a module in theory, but it does work. Like, it is a module that the module system can then deal with. And whatever chaos you did on the class path with split packages, for example, or reflective access, all of that stuff keeps working within the unnamed module. And that's the reason why the class path just works. I brought a diagram here. I don't want to go into too much details because there's a bunch of arrows. The important part is the right-hand side shows the unnamed module, which contains some application, the monitor application that I made up. And there's Spark, SLF4J. Those are all jars that ended up on the class path. They all get bundled into one module. And this module can read all the good Java modules. And that's why it just works. Now, what doesn't work is to reference the unnamed module because it doesn't have a name. And you need a name to reference it. So that means once you start to create modules, what you cannot do is say, well, I wrote modules, but some of my dependencies aren't modules yet. I put them into the unnamed module and will say I requires unnamed. That doesn't work. So there needs to be another way that if not every dependency is modularized, for you to still use it. And that other way are automatic modules. So each jar that ends up on the module path becomes a module. The modular jars become proper, full-blown modules. But the regular jars, the plain old jars, the ones without a module info class in there, if they end up on the module path, they become an automatic module. An automatic module has a name that's either defined in the manifest or that's derived from the jar name. In either case, they do have a name that they can be referenced by. And they also can read all other modules, including the unnamed one, and they can also export all packages. So that means what you can do is something like this. So on the right-hand side, I have, once again, an unnamed module, which contains SLF4J and Spark as before, but it also contains a few other modules that presumably are not yet modularized. On the left-hand side, I have a bunch of other modules called Monitor, Monitor Observer, Monitor Statistics. They're not modularized either, but I put them onto the module path, and they get turned into automatic modules. Right? So what we see here is a situation where I have only plain jars, no modular jar at all, but some of them I put on the module path, and they get individually turned into automatic modules. On the other side, the other ones I put on the class path, they get turned into a single unnamed module. And they can see one another. So this is functioning. This works. This situation, assuming no module does something that's not supposed to, will actually work. So, okay, so that means, as I said earlier, you can put both kinds of jars on both kinds of classes. So that's a little bit, both kinds of paths. So that's a little bit confusing. Let's have a look at what exactly this means. So first of all, you see the class path here. And whatever you put on the class path, whether it's a regular jar or a modular jar, will get turned into the unnamed module, will end up in the one unnamed module. And if you put something in the module path, as I described, you either get an automatic module or an explicit module. So that means while you as a maintainer of a library or as a maintainer of a framework can decide to ship modules or not, you cannot force your users how to use them. It's us users who can decide, well, I can put this stuff on the class path, ends up in the unnamed module. I can put it on the module path where it ends up as its own module. So the user can decide how each piece of code is treated. And that's very important because that allows for varying modularization strategies. You can go bottom up, you can go top down, you can even go inside out. I can't go into detail on these right now, but this allows you to take an application and just modularize the part of it that behaves well with the module system. And once you run into problems, leave those be, maybe report them so they get fixed and focus on something else. You don't have to do it all in one go. You can just do half and then wait for weeks or even months for that to get fixed. So my recommendation is, if you don't have any modularized dependencies, go bottom up. Just start creating modules and then go bottom up in your dependency graph until everything is done. If that doesn't work, you can start at the top or at the, if that's not the case, if you do have unmodularized dependencies, you can start at the bottom or at the top. Both of those work. And the interesting bit is, if you ever run into a roadblock somewhere, as I said, you can continue elsewhere if you want to. And always remember, partial modularization brings partial benefits, so you don't have to push this through. Okay, so what are some common or tricky roadblocks? Before we look at them, it's important to note that most problems originate in dependencies. They often come from automatic modules, actually, meaning a jar that does not work well with the module system for whatever reason that gets placed on the module path. And that can often be fixed by not putting it on the module path, by just leaving it on the class path. So many problems come from jars on the module path that aren't ready to be modules. And so the immediate induction from that is minimize the number of automatic modules. Only put the stuff on the module path that really needs to be there. That's your modular jars and everything they directly require. And everything else you can leave on the class path. And if you do that, most transitive dependencies will end up on the class path where they will presumably not misbehave. If your code directly depends on an automatic module, that does cause problems. So you have a module and you depend on something that does cause problems as an automatic module. What you can always do is you cannot have a module in the first place. You can take that part of your system, put it into a regular plain old jar, and then that can depend on something that ends up on the class path. So that way you can demote the troublesome jar from the module path to the class path so it doesn't cause any issues. And then you can go off and modularize elsewhere. So some common or tricky roadblocks are split packages, broken module descriptors, reflective access, and unsupported media type. The last one is a little bit odd, so I'm going to go into that. The other three I recommend to check out my GitHub. It's nipafx/module system woes, where there's some code and some examples for how to handle the other three. So let's talk about unsupported media type. That's based on a story that Joop told at a conference where he was modularizing a Spring Boot application, and then at some point he got an unsupported media type HTTP error. So HTTP 415 unsupported media type. It's like when he looked into then he saw, like, his story goes, after like half an hour, he realizes, wait a moment, that's not the 415 he was hitting. He was hitting HTTP 415, you forgot to open a package, which is a joke. There is no such HTTP error code. But the issue that he was having is he did not open a package for reflection, and the errors he got based on that was unsupported media type, which was not actually what the problem was, and so it didn't help him finding a solution. So what was going on there? Well, some projects aren't prepared for modules. And the issue with that is that not only do they throw runtime exceptions, they might throw runtime exceptions at points where the original author did not see that coming. So they might catch these exceptions and mistreat them. They might treat them the wrong way. They might catch them and then attribute the misbehavior to a wrong issue. So that's something that can happen. And what you need to do then, if you find an error that just doesn't make sense, is you need to search the log for module-related errors. You need to figure out, is something in the log telling me that the modules might be involved? So for that, as a recommendation, try to increase log level to the maximum and then start searching for these terms: module, lang module, module path, layer, boot layer. The assumption here is that these libraries that just swallow an error will usually at least print it to the terminal, so you can at least catch it there. Maybe there are inner exceptions, so there might be some work here involved. But yeah, so if that does not find anything, but you're still suspecting that the module system might be at issue here, you can take the module system out of the equation. If there's a runtime error, you can just take your app and put it on the class path. Because everything, except the services, that works on the module path also works on the class path. So that means you can always take the entire app, run it on the class path, and except for services, get the exact same behavior. Well, if the module system did cause any issues, you won't actually get the exact behavior. You will get the behavior without the module system, but your app will behave the same way. And that's a great way to figure out what the issue is. So what you can try to do is you can try to create a minimal reproducible example that reproduces your error, launch that on the class path, and if the error is then gone, you know it's the module path. And then you just need to debug harder. And like, I'm sorry, that sometimes happens. Like, it's rare, but sometimes that happens. You just have to go in there and just like try to find the error. Overall, there are two categories of problems in dependencies. Sometimes they do something they shouldn't, and sometimes they don't tell you that something happened. So roughly speaking, these are like two big parts of issues. And you cannot fix those. Most of the problems that you will find in these debugging sessions will be in dependencies. And most of that hard work was already done by poor seps like me, for example, who did this a couple of years ago. So many of these bugs are already fixed. You're not very likely to encounter them. But if you do, and an update to the most recent version didn't fix it, what you're looking at is probably a bug in their code that they need to fix. And if they do, then that makes the Java ecosystem more reliable for everybody. Everybody will be better off if we together find all of these bugs and fix them. And as I just mentioned, for most of them, that's already the case. Okay, so let's say you followed my advice, you used modules, and you ran to one of these or other roadblocks. And the worst possible case happened, and it just doesn't keep working. You cannot keep pushing this way. You know you have to get out of modules. Usually, with most features where you want to do that, that's a really terrible proposition because it's really hard to back out of an API, out of a web framework that you've been using a lot. The same is not true for modules. So this is the Linux command that you would need to get rid of all your module declarations in your system. It's pretty simple. It's a one-liner, actually. On Windows, you might, I'm not sure about that one, but it's probably not much more work. Now, of course, first you have to move stuff out. If you have documentation in there, you have to move it elsewhere. You have to declare services the old way. If you're using command line options in there, you might have to put them elsewhere. And if you have been using JLink, you have to use JPackage now. But overall, you can get out. And that's, of course, not the great value proposition, right? Didn't you just lose a lot of work? And yes, definitely. But what's important also to understand is the module system puts guardrails into place that help you develop a better structured code base. And those benefits were real. They helped you create a good architecture. That architecture is still around. If you wrote good documentation and you move that elsewhere, that stuff is still around. So that means that while it's not great to move out of the module system, you still had some benefits while you used it, and they're still present now. So once again, this is not a great step, but it is possible. That's very important. That makes it very feasible to experiment with the module system. You can start using it. You can play around with it. You can see how far it goes, and I'm pretty sure it will go fine. For the very unlikely case that it doesn't work fine, then you can still get out fairly easily. This could, from even the larger projects, this is probably not more work than an afternoon. Okay, now let's come to when to use and when not to use modules. So first, some observations. Modules do require and enforce a decent architecture. And the work on modules is much, much less work than the work on developing code, right? So presumably you spend hours and hours to create a new feature, even if it's its own jar with its own set of dependencies. In all likelihood, it will take you just a couple of minutes to create the module declaration for that, or to update the module declaration for that. So that amount of work compared to the coding work is much, much less. And then the final observation is that most problems originate in dependencies. Okay, so with those observations under the hood, I'm going to make an assumption. If you don't have particularly troublesome dependencies, then modules are a net positive. They cost some work on the side. It's like putting on a seatbelt. It's some effort. But overall, the effect of that is, as I said, a cleaner and better architecture. And the benefits that I described in the beginning are like more explicit dependencies, better place for documentation, all of that. So my assumption is that we understand that this is a net positive. Now the question is, what about dependencies or other issues? Could they drag it into the negative? Could they make this a negative proposal? And for that, let's first discuss why dependencies are so often a problem. I don't want to harp on them. It's not that anybody is doing anything wrong. The issue is that many dependencies still write code in code bases that target Java 8 or earlier. And yes, you can still create a module declaration, and many projects do, but it comes with more work. And also makes it harder to discover issues that exist with such libraries on the module path. So that means that many projects are on Java 8. They don't work during their daily work on themselves as modules. And because not that many applications are modularized yet, the pull effect isn't particularly large. So that's an issue. But more and more projects do ship as modules. So Christian Stein, a colleague at Oracle, he tracks the number of unique modules. And as of end of September, roughly 4,500 unique modules existed out there. So and that, like, all the big projects are in there, or most of the big projects at least, right? So most of those, they already ship as modules. Let's talk about project size a bit. If you develop a project and it's particularly large or particularly small, how does that impact your work with modules? I would say both of those effects are probably superlinear in size, meaning if you double the size of your code base, you usually have double the amount of relations between them. And that means a module, properly declared modules will have more than double the benefit, but also more than double the work. And likewise, in smaller projects, they have a much smaller footprint in benefits and in effort. So overall, I want to say project size doesn't matter that much for whether you want to use modules or not. The larger the project, the more you have to put in, the more benefits you get out. If we look about project type, then what kinds of benefits do you get? So all kinds of projects get the advantage of managing their dependencies more cleanly. As I said, all dependencies have to be listed. You cannot accidentally use internal APIs from the JDK or elsewhere. You get the new abstraction of a module info where you can add all the documentation. And all of those benefits are regardless of what kind of project you're having. Now, of course, frameworks and libraries have this big advantage that they can use strong encapsulation to guard their own internals from their users. That's a big one for libraries and frameworks. And the other consideration here is that they probably don't want to limit their users. So if users want to use modules, most libraries want to enable that. Now, the interesting bit is, if you look at applications, you could easily say, well, strong encapsulation isn't important. They're the end user. They're not providing code for somebody else. But I would strongly disagree. Somebody else is, if nobody else, it's me in 6 months. So if I write code now and I have to consume that code in 6 months, I will have forgotten basically everything that I thought about now. All the ideas that I had about this is the API and this is just part of the internal implementation. This is the reason why I need this dependency. All of those pieces of information, they will be gone. So if I encode them in the module system, I will also benefit from that. And any non-trivial code base is probably split up into a number of jars already. And being able to erect the boundaries of strong encapsulation between those jars also has a lot of value. And that makes me think that the project type also has little practical impact on the consideration, do you want to use modules or not? But code that is reused probably has a little bit of a stronger argument here. So about project age, if you have new projects, then you can create the module declaration side by side, which is great because that means every time you do something that the module system doesn't want you to do, you can find out immediately, and then you can, apply a proper fix. New dependencies can be vetted whenever they come on board, so that makes it all around a little bit easier. Whereas with existing projects, you might have a backlog of work that you now have to work through, basically technical debt that you have to pay down. And that means that I think new projects are a better fit because they make it easier to get started. An often overlooked factor is domain knowledge. Specifically, what do you know about your domain and the libraries that exist within that domain? If those libraries that exist in your domain are, for example, it's a very niche domain, maybe they're not well maintained, maybe they're very old Java versions, then that can be an issue. Like if the one library that you definitely need to do your job is still on Java 6 and there's no maintainer anymore to update it to the module system, that could be a problem. So if the domain isn't niche and if you understand it well, that makes it easier to use the module system. Okay, so the best place to start, in my point of view, is if it's a new project, if it's a well-understood or well-maintained domain, and if the project that you're creating is going to be reused by other people. All of those three factors make the module system shine all the more. That said, I still think it's a net positive for basically every other project as well. So if you don't have one of these, I think it's still fair to work through your current project and turn that into modules. Unless you have a bunch of dependencies that you cannot update for whatever reason, and there are still very, very old versions. So in that situation, maybe you can get a pass. Okay, so how do you do the updates? I want to recommend to accept that partial modularization brings partial benefits and just start small. You don't have to, make this a big bang thing that has to work from day one. Use module declarations to analyze, guide, document, and review your architecture. So if the module system is throwing stuff in your face, and if you're like, do I really have to export 120 packages from this module declaration? Maybe the answer is no, you don't have to. Maybe you can find a better way to structure that code and improve it, and then make it easier to deal with modules. So listen to what the module system is telling you. Don't get stuck trying to fix dependencies. If you find a root cause and realize, yes, it's this dependency that causes this issue, open an issue, wait for it to be fixed. In the meantime, put everything on the class path and let it go there. And never forget that the modules are a seatbelt, not a rocket. Right? They're not giving you this great new additional technology that will make everything magically faster. What they give you is less moments in which you have to debug dependency hell, where you have realized that you cannot update a dependency because you used internal APIs. We have to dig through outdated documentation, figuring out which services are provided and used. Not having these moments is hard to measure, but there will be these situations, and this is where the module system really helps you. There's a quote that Alex Buckley, who developed the module system at Oracle, used a lot in his presentations, and I want to repeat it here. Everything will be okay in the end. If it's not okay, it's not the end. That means when you're done with this, it will be good. On the way there could be some issues. And that's it for me. I hope you enjoyed this, and I hope you learned a little bit better when to use the module system and when not, and how to approach that. I've written a book about the module system with Manning, so you can look that up. And as I mentioned earlier, I work for the Java DevRel team at Oracle, and we're doing a bunch of interesting stuff online. If you want to learn how the module system works in a little bit more detail, at dev.java, we have an introduction there. Then we have inside.java, which is a great view behind the scenes of how these things get developed within OpenJDK. I can only invite you to check that out. And otherwise, go to Twitter, go to YouTube, to the Java channels, and check those out to get more news. Thank you very much for your attention. Bye.